Welcome to the EE Smarts lesson, It's Shocking, Static Stations. Let's start by looking at this picture. What do you notice? This girl's hair is crazy, isn't it? Why do you think this is happening to her? It's the same thing that happens to you when you rub a balloon on your head. Your hair may stick up in the air just like this. For station 1, the following materials are used: a comb, foil tents, and wool cloth. What do you think will happen when the comb is held near the tents? The comb will then be rubbed with wool cloth and held near the tents again. What do you think will happen this time? Let's see.
As you can see, I have little tents made of aluminum foil, there you can see one, a plastic comb, and a piece of wool felt. I'm going to start by taking the comb and holding it near the aluminum foil tents. Is anything happening? Nope. Now I'm going to rub the wool felt along the plastic comb a little bit. Here we go. And then I'm going to hold the comb next to the aluminum foil tents.
Were you right in what you predicted, or were you surprised? For station 2, the materials used are 2 foam plates and a piece of wool cloth. Do you think that one of the plates can be made to float in air using only these materials? How do you think this can be done? Let's see.
As you can see, I have 2 styrofoam plates and a piece of wool felt. We were wondering if we could get one of the plates to float in the air only using these materials. If you thought about rubbing the wool felt onto the plates, we're going to try that now. First, I want to show you. These 2 plates just sit perfectly on top of each other normally without rubbing the wool felt. So now I'm going to try to rub the wool felt on each of these plates. Now let's see. Nope, that did not work. I'm going to give it another try. This is a little temperamental. What we sometimes start to see happen is the plate will start to hover above. I'm going to take a little bit more time. I might actually grab another piece of wool felt. Let's see if that works. Oh, and it worked. As you can see, the plate does not want to go down. It's being repelled by the other plate. Try it one more time.
Were you right, or were you surprised? For station 3, I have these materials: balloons, thread, tape, PVC pipe, and wool cloth. I'm going to tie thread to each balloon and hang them side by side. I'm then going to hold the PVC pipe near the balloons before rubbing the pipe with the cloth. What do you think will happen? Next, I'm going to rub the PVC pipe with the cloth and hold it in between the balloons. What do you think will happen then? Finally, I'm going to take the pipe and hold it outside one of the balloons. What do you think will happen then? Let's see.
I have 2 balloons that I've tied a thread to each of them, and I have them hanging from the ceiling, as you can see. I'm going to take this piece of PVC pipe and I'm going to carefully put it between them. I'm trying not to move the air so as to not disturb the balloons. And when I put it in between them, you see there's little or no motion at all. Now I'm going to take the PVC pipe and I'm going to rub it with a piece of wool cloth. And I'm going to see what happens when I put it in between. What do you think is going to happen? All right, let's see what's going to happen. Here we go. You see there's significant movement between them. They are being repelled by the pipe. Let me show that again. Okay, Now I'm going to take the PVC pipe, I'm going to rub it again with the cloth, and I'm going to hold it to the outside of the balloons. What do you think will happen this time? Well, let's take a look. The balloons continue to be repelled by the PVC pipe, so much so I could get them swinging. And if I take the pipe now when they get near each other, there we go, and I put it between them, now they won't bounce off each other because they're both being repelled by the PVC pipe.
Were you right or were you surprised? For station 4, I have these materials: soda cans, empty ones, a piece of PVC pipe, and wool cloth. First, I'm going to take one of the soda cans, place it on its side, hold the PVC pipe near it. What do you think will happen? Next, I'm going to rub the PVC pipe with wool cloth, hold it near the soda can again. What do you think will happen? Then I'm going to take 2 soda cans laying on their sides on the table, rub the PVC pipe with the wool cloth, and hold it between the 2 soda cans. What do you think will happen now? Let's see.
For station 4, I have these materials: 2 empty soda cans, a piece of PVC pipe, and a piece of wool cloth. I'm going to take one of the soda cans that's laying on end, and I'm going to hold the PVC pipe by it so you can see what happens, if anything. And you'll notice nothing's happening. So now I'm going to take the PVC pipe and I'm going to rub it with a piece of wool cloth. Notice I'm rubbing in one direction. Now I'm going to hold it near the can. What do you think is going to happen now? All right, let's see. Okay, now I'm going to take the 2 soda cans and I'm going to put them side by side, but not touching each other. So they're nearby, but not touching. And I'm going to take the PVC pipe and I'm going to rub it again. What do you think will happen if I put the PVC pipe between the 2 cans? Let's see if you're right. You'll notice that it gets attracted. They both get attracted to the cans. Now I can pull it out that way, whoops, and I can pull it out this way. But when I put them together, in between, they come together.
Were you right or were you surprised? For station 5, the materials used are salt, pepper, plastic spoon, and a piece of wool cloth. The salt and pepper will be poured into a pile. And how do you think the salt can be separated from the pepper using only these materials? Let's see.
As you can see, I have a pile of salt and pepper, a plastic spoon, and a piece of wool felt. We were trying to think about how we could separate the salt from the pepper using just this material. Maybe you thought about digging each one of those small pepper pieces out, but that would be too difficult and take a really long time. So I think the key is to use the wool felt. You might have thought that as well. I want to first show you, if I hold the spoon over the pile of salt and pepper without touching it to the wool felt at all or rubbing the wool felt on the spoon, you can see nothing happens to the pile or to the spoon. So now let's try. Let's rub the spoon inside the wool felt. Here's our spoon now. And let's see if that made a difference at all. Whoa, did you see that? If you look at the bottom of the spoon, you can see that there is some salt on here too, but a lot of pepper jumped up onto the spoon. Why did that happen?
Were you right in your idea, or were you surprised with what you saw? Now I'm going to show you a brief video describing static electricity.
Do you want to see a really cool trick? Watch this. I'll take this balloon, rub it on my shirt, and gently place it on the wall. And ta-da! It sticks to the wall. Thank you very much. This balloon sticking trick might seem like magic, but it's not at all. The balloon sticks to the wall because of something called static electricity. And static electricity isn't magic. It's science. Do you want to know how I made the balloon stick? Let's start by talking about opposites. I bet you already know some words that are opposites. Like the opposite of day is, that's right, Squeaks, night. And the opposite of up is, right again, down. Well, meet two new opposites. The names of these opposites are positive and negative, and they're special because they attract each other. That means that they pull on one another. If you've ever played with magnets, then you've already experienced things that attract. When I line up two magnets just so, they pull on or attract each other. In fact, when I move them even closer together, they attract each other so much that they stick, just like the balloon stuck to the wall. But I didn't see any magnets on my balloon, and that's because there aren't any. The balloon, the wall, and everything else in the universe is made of tiny little particles. These particles are way too small for us to see. And some of these particles are positive, and some of these particles are negative. They're opposites. And guess what? Positive particles and negative particles attract each other. They pull on each other just like the magnets did. Let's look at my balloon a little more closely. Most of the time, there's about the same number of positive and negative particles in any object that you can think of, like my balloon or my shirt. But when I rub the balloon on my shirt, the balloon takes some of the negative particles from the shirt. Now the balloon has extra negative particles. And when there's an imbalance of positive and negative particles in things, like when the balloon has more negative particles than positive ones, it's said to create static electricity. And when I put the balloon next to the wall, those extra negative particles are attracted to the positive particles in the wall. And the balloon sticks to the wall, at least for a while. Anytime two different things rub together, there's a good chance that static electricity will form. Static electricity is what makes your hair stick up when you take off a fuzzy sweater. And it also can give you a shock when you touch something after walking across a carpet, like a doorknob or another person. So static electricity isn't magic, it's science.
Please keep in mind that in the video you just saw, they labeled the magnets poles as negative and positive, when in reality, poles of magnets are labeled as north and south. They are similar to static in that opposites attract and like ones repel, but magnetism and static electricity do have their differences. After watching the video, can you explain how things worked in the different stations? Let's take a quick look. In the first station with the comb and aluminum foil, when the comb was rubbed, it acted just like the balloon in the video. The comb and the tents had opposite charges, so they were attracted. In the second station with the two foam plates, when they were rubbed, they both ended up with the same charges, so they repelled one another, causing one plate to hover over the other. In stations 3 and 4, the balloons were repelled by the PVC pipe when the charges were the same after the PVC pipe was rubbed with the cloth. But in the soda cans, they moved towards the PVC pipe because the charges were opposite. In station 5 with the salt and pepper, though both salt and pepper are attracted to the spoon, only the pepper tended to stick to it because the attraction is weak and the pepper weighs less, so the salt does eventually drop due to gravity quicker than the pepper would. So you could actually separate it. Not real well, but it could be done. So let's try to sum up what happened in one sentence. Look at the cause and effect sentence starter. Can you complete it when thinking about the stations? There are several correct answers. See how many you can find. Thank you for going through this EE Smarts lesson on static electricity with me.